Oh, good morning, good afternoon, welcome. I'm very pleased to be joined by Alessandra Tedeschi, who is the project coordinator for the ClimaOP project and works for the business Deep Blue, which is a specialist in safety and UX design. So welcome, Alessandra. Thanks for joining us.
Good morning, everybody. I'm very happy to be here.
Yeah. So it's interesting. You're obviously speaking next week at the Sustainable Aviation's Futures Congress, which is taking place the 7th and 9th of June in Amsterdam. You've been working obviously in an interesting project looking at minimizing the emissions in aircraft operations, also including obviously some of the ground emissions. So maybe could you give us maybe first introduction into Deep Blue and then specifically some of the results that have come out of your project and the research that you've been doing?
Yes, sure. So Deep Blue is an Italian SME working in the aviation sector. We are safety and human factor specialists, but recently we are also working a lot on sustainable aviation, always integrating our knowledge with respect to stakeholder engagement and co-design of mitigation and adaptation action for all the stakeholders in aviation. In the ClimaOP Horizon 2020 project, we studied operational improvement for a greener aviation. We worked with different stakeholders, airlines, NSPs, and airports in trying to derive mitigation strategies to support the reduction of CO2 and non-CO2 emission. In particular, in Amsterdam, I will be involved in a panel related to the airport domain and greener airports. And so also in the ClimaOP project, we identified some operational improvement for airport stakeholders. I can provide some details about these 3 operational improvements if you want to know more about that.
Yeah. I assume it's around, I guess, taxiing and also the operation of the airport itself.
Yes. The 3 operational improvement for the ground operation were the upgrading of existing infrastructure according to energy efficiency criteria, so the overall airport infrastructure and airport buildings, the electrification of ground vehicles and operations, and then single engine taxiing, e-taxiing and hybrid taxiing. So these 3 operational improvements have been studied in details through simulation and data from our stakeholders. So we analyzed a lot of data and carried out some computer-based simulation. And according to our results, the majority of the emissions related with ground operation and infrastructure come from the taxiing operation, about the 89%.
Wow, yeah, that's a lot. Yeah,
that's a lot. So that's the point we need to work on through innovative concepts.
And out of those choices, I think you said around single engine taxiing and e-taxiing and highway taxiing. What are those specific approaches? Obviously, single engine is self-explanatory. E-taxiing, I assume, is using an electronic vehicle to take the aircraft to the runway.
Exactly. And this electric towing is very promising because it can potentially cut taxiing emission by up to 50%. So it's really promising, and it works very well for different model of aircraft.
Yeah. And the third option, I wasn't familiar, highway taxiing, I think you mentioned. What does that actually mean?
So the single engine is nowadays the most used. And so the aircraft uses half of the engines for taxiing. So they can reduce the taxi fuel consumption by approximately the 20%. with fuel saving in the range of 2 to 13 kilos per minute, depending of the aircraft type.
Yeah.
So this is already available and very easy to deploy, but unfortunately it cannot be applied in all taxiways or weather conditions because of the maneuverability of the aircraft. So just in some condition and in some airports would be applied. Then there are electric or hybrid tow truck. So the taxi boats, these vehicles you were mentioning, that can, I mean, guide the aircraft and take the aircraft for the taxi phase. And this is the most powerful, let's say, sustainable taxing methods, because the consumption savings are approximately between 50 and 80%, depending on the airport layout and aircraft type.
Yeah.
So there is a strong reduction in emissions, but also in noise. So this is very good. But for sure, there is an extra traffic on the taxiway, more workload for controllers, and so also some potential safety risks. Then there are coupling times that are also critical, and also some infrastructural changes that could be needed to have these tow trucks positioned near to the taxiway and always available, and so on. And then there is also the idea of an onboard electric motor that could be embedded in the landing gear or in the nose wheel gear.
Yeah.
And this can support pushback and taxiing without the normal engines running. Also, this one could be expected to have a fuel saving up to 50%, so comparable to the tow truck. And for sure, this will be always available once it will be installed. And so the planes are completely autonomous, so the operations will be the same as today. But for sure, the cons are that there should be a change in aircraft design. So a lot of cost and investment from manufacturers, basically. And then also extra weight that could then increase the emissions during flight.
Yeah.
So
yeah.
this is also a bit
trade-off.
Yes, a trade-off and a negative impact.
Yeah. And in terms of, I guess, the rest beyond reducing taxing emissions, it's the actual operations of the airports. I assume contracting, renewable electricity to actually run the airport's facilities as much as possible. And seeing increasing actual, projects of, for example, hydrogen specifically, solar specifically at airports facilities. Do you think that see that as a growing trend in terms of actually using some of the space in the airport to actually host, solar power projects?
Yes. We worked a bit on that in the operational improvement that was related to the electrification of ground equipment. So all the different vehicles used for ground operation, from the handlers vehicles to the buses to transport passengers to the gates and so on. And we compared the business as usual, so the current fuel-based vehicles with electric vehicles, with the electricity produced with coal, so the worst case. So, okay, it is electricity, but it is produced with coal, with electricity produced with the U-mix, current U-mix for electric energy production, and also with electricity produced with renewables. And so we see that there is really a big decrease if you use electricity produced with UMix. You have already an 84.1% of decrease in emissions. And if you use electricity produced with renewable, you decrease emission up to 95%.
Yeah.
And then if the renewables are also produced locally with solar panel installed in the aircraft and so on, for sure this will be even better. We didn't estimate that specifically, but we know from other projects and activities that up to the 30% of electricity in the grid get lost. So if you have a local production of electric energy, that will really benefit the efficiency and so also an additional decrease in CO2 emissions.
Absolutely. Excellent. Well, many thanks, Alessandra. There's a lot there to unpick, and we look forward to your panel at the SAF Congress, or Sustainable Aviation Futures Congress. As I said, is fast approaching. We're going to have a great, huge crowd there. I think almost doubling in size from last year. So we look forward to listening more and hearing more about your work. And look forward to the further decarbonisation of the aviation sector. So many thanks, Alessandra.
Thank you to you, and see you in Amsterdam.
Sì, ciao, ci vediamo lì.
Ciao.
Bye.